We're going to continue now to simplify some square roots using the properties that we have for square roots. First problem right here, I want to simplify square root 12. Now the reason that this isn't in simplified form is because there's a perfect square that's a factor of 12. That perfect square is 4. So I can rewrite 12 as 4 times 3. 4 times 3 is 12. Now I have the square root of 4 times 3. My property 1 for radicals says that I can separate that into the product of two separate radicals, the square root of 4 times the square root of 3. Now, this positive square root of 4 is just the number 2 times the square root of 3. So even though that looks a little strange, 2 times the square root of 3, that is the simplified version of the square root of 12. My next problem is the cube root of 24. So is there any perfect cubes that divide 24? And the answer is yes. 8 is a perfect cube, and 24 is 8 times 3. So cube root 8 times 3, that will be the cube root of 8 times the cube root of 3 by property 1 for radicals, and the cube root of 8 is 2. So that's 2 cube root 3. So that's the simplified version, 2 cube root 3 of the cube root of 24, and the reason is because 24 is 8 times 3, and the cube root of a product is the product of the cube roots. Let's keep going. 5 times square root 80. Now remember, these aren't connected together. This is 5 times the square root of 80. So it's going to be 5 times the square root of, what's the largest perfect square that divides 80? How about 16? 16 times 5, is that right? 5 times 6 is 30, 5 and 3 is 8, yeah. So 16 times 5, so that'll be 5 square root 16, square root 5, which will be 5 times this positive square root of 16 is 4 times the square root of 5, and now 5 times 4 is 20 times the square root of 5. So it might not seem intuitively true to you, but it is in fact true that 20 times the square root of 5 is exactly the same as 5 times the square root of 80. Now if you want to check this, you can take your calculator and multiply 5 times the decimal approximation to square root 80 and look at 20 times the decimal approximation of square root 5, and you'll see they come out to be the same decimal number, just to back up what we're saying right here. Let's try another one, 3 square root 50 xy squared. Let's write this as 3 square root of, okay, 25 divides 50, so I'm going to write this as 25. Y squared is a perfect square, so I'll write my perfect squares first, times 2x. Now, isn't this expression the same as 50xy squared? But what it is a perfect square times a non-perfect square. So this would be 3 square root 25y squared. And remember, I'm assuming that all my variables represent positive numbers. This is 3 times the positive square root of 25y squared is 5y, square root 2x, and then 3 times 5 is 15. So I have 15y square root 2x. I know that's getting a little small down there, but that's the simplified form of this expression right here, and I put it in simplified form by taking the largest perfect square that's a factor of what's under the radical out from under the radical. Let's try one more problem. Here I have square root of 128 over 49. I'm going to use property 2 for radicals to write this as square root 128 over square root 49. So the property 2 for radicals says that the square root of a quotient is the quotient of the square roots. Now, square root 128, let's see, that's 64 times 2. So that's square root 64 times square root 2. And square root 49 is just 7. Square root 64 is 8. Square root 2 over 7. Now, a lot of times on the videotapes, I'll say square root 64 right here, and what I mean is the positive square root of 64, because 64 has 2 square roots. This is the positive one. If I put a negative sign in front of that, it's the negative square root. In any case, this is the simplified version of this problem right here.